Well, hello, hello. If I stream, will they come? Oh, hi, Sarah. Hello, hello. I've just been working on some power supplies this morning. Good morning, David. Hello. Been doing. I was starting to work on some power supplies I have in a box, and then Joey went to streaming. So I see the coder must be streaming. Well, go where you must. The coder. I wonder if Phil was waiting for Joey to stop. Hello, Picotronics. I was just working on some power supplies. Like I said, I have a box full of them here, and I was going to live stream. Good morning, Stroke Fixer. A lot of people coming in. Hey, Rusty Russ. A lot of people coming over from Joey. A lot of them going over to the field. That's all right. I am. Some of you are joining late. I'm working on some power supplies. The first one I worked on is already done. Sorry, y'all missed that one. I wasn't streaming. That's it right there. It was just swapping out the controller, the DAP053. That's all it needed. So the next one, however, has not been so nice. It is a lightning struck, and I have been swapping out components. I have not even applied power to it yet. Have not even tried to turn it on yet because there were, components obviously blown apart. So I've been swapping out the stuff I could see. Even one of the opto isolators right here blew apart, which is kind of rare. You don't usually see those pop, but it did. So I've been swapping out, and I got a feeling there's a lot more wrong with this thing. May not get it fixed in this stream, but we'll try. But I've already replaced the DAP053, the controller. Replaced that. Replaced this opto isolator. Replaced several MOSFETs, these tiny MOSFETs. Some of them over here on the cold side. And I got a feeling that's not going to be all of it. Let me look under the microscope and see if I see anything else cracked open. Anything else that's cracked open. But yeah, I was getting ready to clean some flux. I guess I got that pretty clean. Swapped that out. I still see some flux there. I replaced this Zener, which connects to pin 2 right here. But that wasn't the problem. It ended up being, if you follow that connection, it goes around here to this MOSFET right here. 704, I think that's a MOSFET. Yeah, 2N7002 KT. So that was shorted. I got rid of that. I need to make sure. I think I had a short across this Zener as well, which I don't think I will now. A lot of those shorts were the DAP053 having died. Okay, yeah, we're not shorted there anymore. But I'm kind of half expecting this opto isolator was busted open. The whole top was blowed off of it. This resistor was opened, which connects to that. No, it actually connects to this opto isolator. I wonder if that one's bad. This resistor was burned open. This MOSFET had the top blown off of it. This one had the top blown off of it. So yeah, a lot of destruction. And I have not applied power to it. I just have a feeling I have not found all of it yet. I did the MOSFETs. Where are those MOSFETs? The MOSFETs for the, you know, during the 12 volts. These two, Q31 and, no, Q3 and Q4 here. Replaced both of those, replaced the little fusible resistor right in there. It was open. The fuse is fine though, so there's that. Okay, I was just checking across the output terminals. There's no short there, but I don't really think she's fixed. I need to go back and look at this. Like I said, this resistor here, this 1000 ohm resistor, was open, and I thought it connected to this opto-isolator, but it looks like it connects to this one. So, well, I measure 1 volt across that. This would be the LED side of it. This would be the anode. This would be the cathode. I'm getting 1 volt there. That doesn't look bad. This little reference IC may have popped. I've got those. I guess I could check it in diode mode. If it's going to die, it probably will die in some subtle way where, you know, it doesn't show up until you apply power to it. 0.2. That's suspicious. These ICs here, I really need to check my notes. What about these up here? These little MOSFETs. I've seen them blow apart with lightning. Oh, yeah, there's a short. Well, no, there's not a short. No, sorry. Yeah, that's what happens when you when you apply voltage to the gate. You latch the thing on. See, if I were like reverse these, see if I can turn that thing off. Yeah, see, now it's off. Yep. Oh, sorry. Make sure that's in the picture. So this is the drain source. If I go across there, look, it's not shorted. I'm in diode mode. But if I do this, tap that gate. Oh, now we're shorted. Oh no. So, but I'll just reverse it. Tap. Now it's off again. So, anyway, that's why it beeped, because I triggered it on. I triggered the gate. Hello, everyone. Dave's on Brandon. When are you streaming? I haven't seen you stream. I thought you were doing some setup. J-Fix. A lot of people coming in. Welcome, welcome. I guess I need to. I need to look. Let me look around these ICs and just see if I get any dead shorts. Just have a feeling. Well, there was just a lot of carnage. Where's pin 1? I need to look at my notes. And I guess I need to get my on-screen meter set up, because you can't see my meter. This pin 3 right here is reading 0.07. Notes. I know I have some notes. Let me find them. Printed. No, I do have my. Where's my notepad with my notes? Yeah. The ancient texts. Gives me something to go by, though. MK Fix, hello. Welcome, welcome. Maybe I can just do this. Can I get all this in the picture? Yeah, I've got a pile of components I have replaced. Yeah, negatives toward the outside, so I'm going to go right there. Which IC is this? IC 131. Okay, here. Yeah, that's not going to be right, is it? Pin 1, that's not right. Should be 0.633 on pin 1. 2, that looks good. 0.67. 0.07 on 3. Yeah, that's not right. Should be 0.6. That's ground though. I think we're good there. 5. That's fine. 6. Pin 7 is slowly charging a capacitor. Should read 0.63. 0.633. Yeah. That's supposed to be 0.4. We've got a lot of stuff going wrong here. What about this other chip down there? This is IC 101. That one. Where's pin 1? Right there. That looks good. 2 is ground. That's correct. 3.65. That looks fine. That looks fine. Ground on this pin. On 5. Yep. Pin 6. Fine. 7 is also low, but 7 is going to be, I wonder if that's the power supply, which would be 12 volts probably. Yep. So the power from the 12 volt output. So that seems low. But there's a lot of capacitance, so it's going to, anything that's here is going to be slowly changing because there are literally thousands of microfarad of capacitance across those output terminals. What about that one? This number, okay, yeah, 8. Okay, I don't know on that one if that's good or not. I'm thinking about removing this IC 131 though, because of, we had a, yeah, like pin 1, 0.18. That's not right. And there was another one. Yeah, 3. It should be 0.6. I don't think we lost our rectifier MOSFETs. They're rarely used as rectifiers because you normally get a short across the output, a dead short when those go. Nothing seems to be shorted, not a hard short anyway. I do want to take off this IC 131. Need to see where that goes. Like 1 and 3. What are they connected to that's got such a low resistance? Hello? Oh, Steve is here. Carthor, hey. Swindon, David, Andy is here. Dreams? Wow. Everyone from chat or from Discord is here. What were the symptoms? Components blown to pieces. This power supply came from, I have a box of power supplies behind me that were given to me by a guy who owns a shop in, I think he's in South Carolina. He doesn't work on supplies and offered them to me. So I took them. Has my battery died? No, it didn't die. And I'm just I decided to start going through some of them. And the very first one, I just replaced the DAP053. That worked. She's off and racing. But this was the second one I grabbed out of the box. And it had, I have not applied power to it because it had components just blown to pieces all over the place. Opto isolator, several of these tiny MOSFETs. There's obvious arc marks. You can see the little marks between some of the component legs sticking up where you know, current jump between points. So yeah, it's had a hard life. Let me take this IC off. This, I think it's, let me go to the microscope. Is that the DAS 01B? Yes. Because I'm getting some low readings on pin 1 and 3. So I want to take that off. Let's just see if those low readings go away. Try to limit my air temperature to 350 on these boards because they will popcorn on you very easy. And try to keep that heat moving. Yeah, but they're also, all these components are glued down as part of the reflow process. All right. I'll hang on to that. I don't know if it's bad or not. Now. Now. It was 1 and 3 where I had the low readings. Now I have no reading on 1. Nothing on 2. Nothing on 3. Yeah, 4 is ground, so that's fine. The meter's working, but yeah, nothing on, with that chip removed, nothing on 1, 2, or 3. 4 is ground. 5 is reading high because, well, the chip's gone probably. 6, nothing. 7, nothing. 8. So, is that the only? There's my DAP 053. Is that all it got? Not likely. Let me find that chip. DAS 01B. I have some. I don't have a lot of them. I haven't used one in a while, so I've got to hunt it down. DAS 01B. Unless I'm replacing it with something else. I don't think I am though. I thought that I had found some of those. DAS. Oh, here it is. Yeah. Plainly marked. Oh, looks like I bought 20 of them, and I have used 2 of them. Hello, welcome. Yeah. Well, thank you. I do like working on power supplies. I know a lot of people don't. I get it. I actually I bought it off eBay, a broken 400 FR. Just because the guy, I was watching it and he shot me a good price on it. I don't need the thing, but I bought it anyway. Because I'm sure I have many broken 400 FRs over here. See if I can line this up. So I don't know when that's coming in. Oops. Sorry. I know you can't see. I'll switch to the microscope because I got to fight this thing. Get it to spin around. All right now. Just spin. Stay there. Close enough. I may have to open up another DR for some measurements. Here, we get this thing going. I didn't scrape that glue off underneath, so it's making it shift all over the place. All right, just stay there. Pretty much have to grind that glue away. Okay. There's only 2 ICs, on this, true ICs, you might say, on this side of the board, and there's the other one that didn't check bad. All right, let me clean this up a little. Just a little. I'll have to go back. I put so many components on this board, I'll have to go back and heat it up and brush it really good with the toothbrush to get rid of all this flux. Not much point in it right now though, because I'm going to put flux right back down probably. Okay. Let me go. Hello, people still coming in? All right. I'm going to check on the pins of that chip I just changed out. Yeah. Yes. Yes. Ground is fine. All right. That chip was definitely bad though, because all those low readings are gone. Except for that one. My note said 0.463, but I think it's going to be after it charges up those capacitors. Yeah, now we're at 428. Because that's going to be connected, I'm rather sure, and this is a resistor involved. That's going to be the supply, but it's probably going to be straight connected, to the output terminal. That's the plus 12 volt outputs. Probably there, and on this pin 7 down here. Yeah, I think there's a 10 ohm resistor in line with that one. So, that looks good. Looks promising. I don't think it's going to work. It's a 100 ohm resistor. I just have a feeling. I have swapped out several of these little tiny MOSFETs, the ones that were obviously blown apart, but there's going to be, I'm afraid, there's 2 or 3 other ones on this side, on the cold side, that can cause shutdowns. And I got a feeling 1 or more of those is going to be, will have broken down and failed in not so obvious ways. Just a feeling. I have replaced, I don't know if you can see them all, that. Some tiny MOSFETs. The opto isolator, there's the pieces of it. It fell apart taking it off the board. It was already blown in half though, so it wasn't far from gone anyway. Should I put power on this thing now? And I don't think it'll catch on fire or anything. I think it'll just shut down. Okay, let's do that. What I'm going to do though is bring it up slowly. Because I'm on parts bins, I've been out putting parts in this thing. Luckily, These parts are rather cheap. Let me clean up a little bit. Well, hello, who else is coming in? Power it up. You're very enthusiastic there, Carthor. Very enthusiastic. Okay. Let me get set up. Let me switch cameras here. Yeah, like that. Let me get where you can see. Oh, it's kind of in a bad spot, isn't it? You can't see the load. I guess I could just move the thing. It's not like I can't click right there and just go wham. You go over here now. Magic. This camera is not wanting to focus very well, though. All right. Let's get this load connected. I'm thinking about making some new leads for my dummy load, and using double wire. Just 2 strands of the red, 2 of the black, and bundle them together. Just so I don't have so much loss when I go across there, and it makes it look like the voltage is really low. Let's see, AC voltage. Let's dial that down. I need to get set up. I want to watch the power factor correction voltage. This meter went to sleep. We're going to get across these big filter capacitors right here and hope they don't go to 600 volts. Alrighty. Load is on, and I am set for 10 amps. Let me back that down. Let's just say 5 amps. Let's start off slow there. All right. What do we think? Is it going to work? Thermal cam? What's a thermal cam? Yes, it is a Variac. Not a very high power one, but it's, it does quite well. It's capable of 2 amps. Which is usually more than I need for just checking out a supply or something. All righty. All right. Let's see what can we get that out of the shot. All right, I'm going to bring it up slowly here. I want to say somewhere around 90 to 100, or right around 100 volts, let's say, is when it should start trying to, let me get my arm out of the way. Should start trying to run if it's going to. I don't believe it. It came up and ran. And looks right. 395 volts here for the power factor correction. I did not expect that to start. Wow. Well, that was easy. Time to end the stream. Oh yeah, the knob is not. Yeah, it is kind of. And if that knob it's a wiper across windings of a transformer, so you feel each like plump, plump, plump. You feel each detention. I mean, it's smooth, but you can feel as you wipe across the windings. It's going to be like a carbon contact wiping across those windings in there, and you can. It's a very satisfying feel. You feel like you've done something. How much current are we drawing? Not even 6 cents of an amp or something. All right. I do need to turn it up, but we need to see if it'll supply a little more current. Let's go up to about 10 amps. All right, 10 amps, 120 watts. And this is what I was talking about, that the reading 11,934. I bet you if I put this meter on there and you right across the terminals. Like this doesn't have like a remote sensing connection. I think some loads are fancy. You know, if you've ever seen like a 4-wire connection for a power supply, it'll have remote sensing. It'll measure the voltage right across the terminals and feed that back. But I don't have that, so I'll just have to stick another meter on here. Let's just see what we have right on the terminals here. 12.056. So, but if I were to double up these leads, you know, which I think this is 14 gauge wire, if I had double those up, you would have a more accurate reading here. Because I think, like it says 11.935, I think that's what you'll actually see right here across these terminals. Yeah, see? So, yep, wires are not perfect. Pretty good, but I'm putting 10 amps through it right now, so that fraction of an ohm of resistance that it has kind of adds up. Times 2. The positive and then back through the negative. Anyway, so I think this is going to work. I'm running at 10 amps. I will. JFix, yes, I have replaced many TEA 20 DAP 053Ts with TEA 2016s. It does work. It doesn't work quite as well to me. It does work though. That's why I bought some DAP 053s, but I've got 200 TEA 2016s. I assure you, I have many of them, and I have more of them in a bag. When I noticed, yes, it works, but as you ease up, as I adjust this load, it seems like the power factor correction voltage likes to get a little unstable, somewhere around 4 amps or something. And if I keep going though, it smooths out and everything's fine. But it was just a little bit unnerving, so it will work. It's not a perfect fit. I do believe a DAP 053 is a TEA 2016 with special programming. And looking at the data sheet, I don't think we can program them. I think those pins are disabled. I think you can order them. You know, you can order some TEA 2016s and with the flag set the way you want them. Hello, hello. But I've replaced many a DAP 053 with the TEA 2016. Now the DAP 056 used in the slim power supplies, I use a TEA 2017. I just find it works a little smoother. But yeah, just an opinion. The DAP, if I put a DAP 053 in here and if I crank that load up, it's just rock solid. The voltage doesn't wander around. Like there's 1 amp, and you can crank it up to 3. It was around, I want to say it's around 4 amps or something, 4 or 5 amps. This PFC voltage just starts bouncing around like 10 volts over, you know, it's just unsettling. Like if you go below it or beyond it, everything's fine. So yeah. But I was able to get some DAP 053s from Case and Parts. With the tariffs they threw on there, they were about $10 each. And I think I have 8 left. Yeah, right here. 1, 2, 3, 4, 7. I think that's 7 I have left. But we may do that. If I do another supply here in a second, we may just put a TEA 2016 in and I'll show you what I'm talking about. Let me unplug it from this thing. This supply is only good for about 2 amps. And like right now we're running, well, I turned this down. If I turn this up to 10 amps, so we're running about 1.25 amps. And like I said, there is a slow blow 2 amp fuse in this thing that I have blown before. So beyond 10 amps of load, I need to plug it in the outlet back here. I need to bypass this, go straight to the outlet, and we'll just run it up to 30 amps or so. Let me get I've got a little desk fan here. I need to, you know, put a little air across this power supply just to help keep it cool. No need to burn it up after repairing it. Although it does have, there are temperature sensors on the boards, like near the PFC. Usually there's a couple of temperature sensors, negative temperature coefficient resistors that will shut it down if it overheats. But I've just got a fan going across it just a little bit there, because I'm going to wind it up to about 30 amps and give it a proper. These things are rated at 31 amps. Now the PS5 does not use 31 amps, but of course you got to have headroom. Always need some headroom. All right, I'm metering right across that 12 volt output terminal. All right, we're at 5 amps. I can turn that off. Hope I don't trip a breaker here. 6, 7, 8, 9, 10, 11. Bring it on up. 15 amps. We're still rock solid here. And there. You may see this drop a little, but it's not much. 20 amps. Looking solid. My leads may start melting, but we won't leave it on that long. There's 30 amps. That's usually as high as I go. Okay? She's rock solid. PFC voltage, output voltage is fine. We'll wind her back down. Alrighty. That's a good supply. That will run. That will run. Could end horrific. What do you mean? Nothing bad's gonna happen. This load that I have, 150 volts, 40 amps, 400 watts. So you can't do 40 amps at 150 volts. So, you know, there's the limit of 40 amps of current, 150 volts DC, and 400 watts dissipation. And I guess we just hit, what do we hit, 360, would it be? What's 12 times 30? So, and it has an internal fan that has ramped up in it there. Anyway, I think we're done with this one. Where am I? There's those DAS. I haven't used too many of those. Haven't had to use too many of these chips. I want to say they were kind of hard to find. I'm sure I got them off of AliExpress or Kaysen. The DAS01B, that is. All right, put that up. Let's shut her down. All right. Oops. I'm dumping dead parts in the floor. Let me throw this in the garbage. There's some of the parts we changed out. To the trash. Oh, and along with these, you know, the main MOSFETs, switching MOSFETs for the 12 volt generation. And the fusistor, or fusible resistor. Oh, no, I just dumped all my DAP053s. I need those. All right, I'm missing one. Where'd it go? Here it is. I forgot I had knocked the, I'd taken the tape off the end of the sleeve. So I tilted it the wrong way and they all decided to abandon. All right, 6. I have 6 now. And then there were 6. I should have gotten more of those, I guess, but I have plenty of the TEA 2016s though. I was making a list of some of the things I was going to have to change. Pieces of the opto isolator in the garbage. Okay. I unplugged this thing, didn't I? Yes, I did. Let's bleed off this charge on this filter cap. if I can get on the thing. I slipped. There's been once or twice that I've gone to bleed off these capacitors and forgot that I still had the thing on. So it's sitting there trying to, why is this not discharging? Because you left it plugged in. Hasn't happened too much though. Alrighty, get that off of there. Okay, Steve, see you later. Alright. I do like these, I don't, not all of them this way, but these 400 DRs, the early supplies, they're this real pretty green color. Later on they switched to just the, you know, kind of blah beige color, but these have this really deep, like an emerald green. Just looks cool. Alrighty, and there's also, this thing has to snap. Alright, snaps in there, snaps in down there. Top cover, or bottom, depending on how you want to look at it. Alright, screws, and I gotta get that big X off of there. Somebody, the guy I got it from marks it with an X because it was dead. And it looks red, but when you take it off with a cotton swab, you can see that it was a blue Sharpie. Now I need to mark this as being a good ADP to a 400 DR, which I need to get some of those labels made like Andy has. I wouldn't mind having just some that just say repaired, which I think you can get those off Amazon. ADP. I write this on here for my use when I'm digging through looking for a spare supply, so I don't have to get the light just right to read that. I can see it. And for some reason, I always stick it on this side. No, I guess I can do it like that if I want to. Of course, that's not going to stay. So, a little bit of clear tape over it. That looks professional, doesn't it? Well, it's just for my use, I suppose. So there's the second one. Oh, there's the first one I did earlier today. What else do we have in the bag of goodies over here? Hey, Slug. Let me check my messages. I purchased a non-working Xbox Series X to work on, and it's like 3 days ago, and the guy hasn't shipped it. So I messaged him, "What's up? Is this shipped yet?" And he says he did not get a notification that had been purchased. Okay. All right, I've got another 400 DR here. what is this one? Another 400 DR. There's so many of these things. What is this one? Another DR. What is this? Another DR. There's also some PS4 power supplies in here, which I haven't worked on in a while. But I'm not opposed to it. I'm not scared of them. I was looking for, like, see if I could find an FR. There's an FR, complete with antenna. So that's a possibility. We'll do something a little different for this next one. And this is a, what is this? Oh, there's another FR. Okay. And this is just some of them. I have probably another 10 in this box. If you like power supplies. Apparently no one likes power supplies. A lot of people left. Hello, hello. People are leaving in droves. Oh well. We can still work. All right. 400 FR. From the 1200 series. Let me get this antenna out of here. I do have quite a few of these antennas. Yeah, I was up to 50-something people, and then went down to 28. I'm disheartened. So disheartening. All right, I'm not going to bother testing this thing yet because I'm assuming it doesn't work because he wouldn't have given it to me if it worked. Let's just see what we can do with this. Oh, come on. There we are. Oh, we have a dead roach. So this is going to be likely a roach-killed one. I just see the one. Well, actually there's two. Not sure how well that shows up on camera. Right down in here. There's one and there's the other. And I was trying not to move them because sometimes it's helpful to see what they're laying across. So you kind of know where the current may have went, you know, that it shouldn't have gone. I don't see any burn marks though. Like quite often there'll be an arc mark. Nothing obvious. Is our fuse good? Let me clear. Yeah. All right, is our fuse good? Fuse is good. Fusible resistor. Oh, I see a problem now. Now that I've turned the board over, this MOSFET right here has given up. Yeah, I think that's Q4. So the fusible resistor R9 is open. MOSFETs are shorted. Okay, that's problem number one. Knocked my dead roach friend off. He killed that MOSFET or MOSFETs. Okay, let's get these MOSFETs off of here. Where'd my flux go? Hello, anybody else come in? Still lurking? Where did they go? Where did what go? I'm sorry. Oh, the people? I don't know. They want to see if I have a Kick channel? Yes. Look for me over on Kick. Go ahead. You won't find me there, but you can look for me. I mean, I'm not even on Twitch, which I've always thought was Twitch is a gaming channel, which I think that's how it got its start anyway. Streaming gamers. But, you know, streaming platform to streaming platform. I'm just heating up all the pins at once with this big, got this big tip that I use on HDMI ports, and they're out. And I may do the same thing with our fusible resistor here, R9. Out. All right, I'm going to clear these holes, and then we'll check the DAP053. It may have survived, who knows. All the readings won't be correct, of course, because our MOSFETs are out. So the drive pin for the upper and lower MOSFET will read higher than it should. I think it will anyway. Some of the connections tend to read a little higher, so it won't be exactly right. But we're looking for we're going to be looking for shorts though. All right, let me clean that up a little. Just a little. All right, looks clean. What else did we get though? Yep, pin 1 is in this bottom left corner. Let's just see. Where's my negative terminal? Oops, get my leads right. All right, pin 1. That meter in the shot? It is. Come on, that looks good. 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 4 is ground, that's fine. 5, 6, 7 is no connection. I think 7 is it's a spacer, but I think that's also where the programming would have been. One of the pins, anyway. Yeah, that's going to read high. It should be like 1.15, but it reads high because the MOSFETs are out right now. That looks fine. That's going to read high also because the MOSFET's being out. I think that's a no connection on 12, 13, 14, 15, 16. All right, it doesn't look bad, so I'm going to leave it in there. It may not work, but let's take a quick look at the PFC MOSFET. Make sure it did not die in all the roach crawling around. I'm going to say no. And the diode never really goes bad because it's tough. That is a tough, strong, the diode for the PFC, for the boost voltage. Ooh, we got a swelled capacitor. Well, is that showing up on camera very well? Some swelling may have occurred. So either that capacitor was failing or during all the roach damage, that voltage, the PFC voltage may went beyond 450 volts. Alrighty, we need to swap that out. 150 microfarad at 450 volts. Do I have any? I happen to have some. Yay. What a coincidence. And I have 2 left. I'm sure I started out with 10 of those. Well, hello. Oh, hi, Ivan. First time. Yeah, I don't do a lot of live streams. I'm trying to do more and more. I'm trying to do more and more. Back to, yeah, the count went back up. Flux the Roach. He's had enough. He's done. Roy, yeah, you don't work on supplies either. I understand. I probably would take some, but I don't know what I'm going to do with them. I need to sell them, I guess. I've got so many. I don't need that many. You know, I need 2 or 3 spares of each type is what I need. Not 20, which is kind of what I have. Oh, I need let me get my hot glue gun set up so I can glue that back down. This is what I've been using to glue them back down. Anyway, you could use like some silicone caulk, whatever, Celastic, whatever you want to call that stuff. But I'm just going to use some hot glue. Okay. Let go. There we go. If I can get that off. I have to clear those holes. The capacitor still has a good weight to it, like it hasn't dried out. Look at can you see the top of it there? But she has come very close. Well, it looks like it has cracked open, like it vented. Now maybe we'll look at it under the microscope. It looks like it may have vented, but I don't see capacitor juice everywhere. There is a electrolyte in there. And when they pop, it usually spits it out, unless it's already dried out or something. Okay. Negative. And of course, the leads are bent exactly the wrong way from what I need. Oh, there we go. Let's see. And where'd it go? Oh. Okay. Yeah. I think I got those leads spaced about right. All right, that should do it. At least it won't bounce around. Unplug that and get it out of the way so it can dribble glue somewhere else. I know it's going to. Get off my fingers. All right, so we replaced that capacitor. We got to put these MOSFETs in there. MOSFETs, fusible resistor, 0.1 ohm, 2 watt fusible resistor. Let me take a look at that. I want to see if this. I'm going to look at this top of this capacitor. Let's just see. Yep, it did vent, didn't it? Look at it there. Yep. All the smoke had come out of that one. You can see all the layers. There'll be layers of aluminum foil and a paper-like substance soaked with a dielectric. Cool. But yeah, she blew up. That's the technical term. She blew up. So, capacitor. Let's put some MOSFETs in here. I may have to get some more. These MOSFETs that I'm using, I think they're being discontinued. That's what I replaced these with. I don't know if you can see the part number. It's a Mauser part. The original ones, I believe, are 18 N60 M2s, and I had trouble getting them. I did finally get some, if I can show you, from AliExpress. Look at this. And I got to looking at them, and these things have got to be fake. They were so cheap. So I've never used them. I've got a drawer of them here, but they were so ridiculously cheap. I was like, these can't be real. So they've been sitting in a drawer up here since I got them. I don't know, maybe I'll be brave enough one day to pop them in a power supply. In the meantime, though, I'm going to use these, I think these are on semiconductors. I've got a few of them, but then again, they go two at a time, usually. So what I'm replacing here, just a second. I like to get them. One moment. I'll show you what I am replacing. I don't want that. Just a moment, I'm looking up something. ADP 400 FR AAC. I think that is it. Screen capture. I don't know if I need that. Okay. So if I go to that, nothing happens. Oh, I think I see what happened. Let me hide that. One moment, I'm trying to learn something here. Why are you not working? Oh, I see why. Because I was an idiot, that's why. There you go. You can see that. There's those MOSFETs. And you can see the original part number, 18N60M2. And up here, you'll see the fusible resistor in line with the boost voltage. Kind of cool, isn't it? Oh, yeah, I can test those out of circuit if you'd like. But they were shorted in circuit, so I don't think they have miraculously healed themselves. Continuity mode. Okay, short between those legs, short between there. All right, all three legs shorted on that one. This one, short, 1.5 ohms. This would make a really nice 1.5 ohm resistor. Yep, they are shorted. And then the fusible resistor has done its job. Open. So I have not soldered these MOSFETs in there yet. They're just sitting in the holes. It won't stay there very long if I don't get them. Okay. Let's see if we can solder that down. And while I'm soldering, I should have gone ahead and put that little fusible resistor in there too. All right then. Oh, I need to cut the legs off the MOSFETs, don't I? Oh, hey, David, we're trying to finish up on another power supply here. I don't know where you left, but this is another power supply, the second one in this stream, and it was a victim of this fellow. He gave his life to take out this power supply. So now we're trying to undo what he has done. Should probably clean where I soldered that big cap down. I think we're ready to test this. Unless I've forgotten something. So we had two bad MOSFETs, the ones for the generating the 12 volts to drive this transformer here. PFC MOSFET looked fine. Fuse is good. Replaced the fusible resistor. Yeah. The DAP053 controller doesn't seem to be shorted. Oh, we did replace that capacitor. That was not shorted, but was not well. All right, let's get set up. The usual, all the usual things. Where's my meter? For monitoring the PFC voltage, power factor correction. Okay, where's my AC input? All right, let me get some junk out of the way here. All right, are we ready? Let me switch where you can see something maybe. Is that better? That's not really better, I don't think. That's easier to see, I think. Anyway. Okay. Load is set for 5 amps. It's on. AC is off. Load is connected with the polarity right. We're meeting across our new capacitor that we just put in. I think somewhere around 100 volts, you should see it start trying to do something. Is that in the way? I'll bring it on up. Something's not right. Something's not right. How high did that go? Nope. That voltage is not wanting to come up. Let's check the current. There's a short somewhere. Yeah, that is not right. That is not right. So, and also I'm so used to this little variac. Whenever I can tell when there's a short because it starts vibrating. I can feel the vibrations through the knob, and you can hear it humming. It's like something's not right. So we have a short somewhere. Where is it? Where is it? Yeah, there was some tactile feedback there. It was humming, and the current's going way up. What did I do? We're only 1.6 across our capacitor here, so it discharged itself very nicely. Trying to think. I did not look across the output. I don't think there's any shorts. I'll check it though. We've got something. Something is shorted because it was drawing a lot of current there. which is that's what's handy about that little variac. I can bring it up slowly. Continuity mode. Don't. Surely our MOSFETs did not go. Don't think so. Something. Fusible resistor. I can't really get on it. All right, the MOSFETs we just put in look fine. I'll switch back to the other view. Yeah, these MOSFETs look fine. There's no short across our output terminals, is there? No, we just charged up our capacitors. Well, I'm in continuity mode. Let's get out of continuity mode. Get out of nano Siemens. Oh, we're in the megohms. So, no dead short on the output terminals. So this is most likely on the input somewhere. Our bridge didn't go bad, did it? I doubt it. These bridges are tough. No short on the bridge. What do we read across our filter cap? That other filter cap could be bad. I'm in continuity mode. I'll just go into resistance mode a second. What do we have right there? We have in the megohms, but there's probably a little bit of charge across that cap right there. Not much, but it just keeps charging back at like 1.5 volts. So I really can't get. Well, I tell you, there's no short there. There's 1.5 volts sitting on that capacitor, so there's obviously not a short or a low resistance there. So is it just our DAP053 is bad? Which is a good possibility. We'll hit some of these diodes here. I'm in diode mode. That looks good. That looks good. Some of these larger diodes, they don't usually fail though. And see, this was not lightning damage. This was roach damage, I'm pretty sure. I'm assuming, but there was a roach in it. You know, maybe that's not what killed it. Let's just check our DAP053 again. Pin 1 looks fine. 2 looks fine. 3, 4 is ground. 5, 6, 7, there's no connection. 8, that looks fine. 9 looks fine. 10 looks fine. 11, is that right? 0.5. Yeah, that looks right. And it's not checking bad. 12 is no connection. 13, 14, 15, 16. That looks fine. The way that thing was humming, I don't think the voltage went above like 70 or 80 volts or something. I could break out the thermal cam. Nah, there's no point in that. There's no point in that. Well, that's across there. Let's go this way. No. And our PFC MOSFET was not bad, right? Oh, Worms is not around? Where is he when you need him? The diode readings look fine on that. It could still be bad. Let me make sure this PFC MOSFET is still good. Let me look at some diode readings on my notes here. Uh, 0.706 on the gate, 449 on the drain. Where was I? Where was I? Up here. Yeah, there's the gate. And there's the drain, 449. And this is ground on the source. That PFC MOSFET looks just fine. The diode is not shorted. Nope. So what's going on? Why were we humming so bad? I mean, I'm assuming we didn't have a problem on the cold side because, you know, the roach was on the hot side. I was assuming that all this over here is fine. We'll give it a quick check though. The DMP 014. I'm just looking for anything shorted. I think we have a ground coming up. There is it. Yeah, there's ground. It's charging up. That's fine. 0.23, is that right? That's on 14, 13, 12, 11. That may be right. That looks healthy as can be. I don't see a problem. Let me see. Pin 11, yeah, 244. So the DMP 014 looks healthy. I'm trying to look at right here. There's still a little bit of discoloration in this area. That's where that roach was. So if something is shorted, I should probably look in that nearby area. But the way this thing was humming, let me look around. Let's look around on the microscope, because I will break out the thermal cam. I mean, you can, if you see how it's kind of discolored right there, and you can also see a little bit of corrosion right there. So that's where he was walking around. So, did he get something in this area? Don't really see much. It's a small diode. There's a large diode. I have not put a meter on these opto isolators, but I mean, this seemed like it was drawing a lot of current. There's that capacitor. We changed one of them. There's a solder ball rolling around on the board. I'm not sure what happened to my tweezers there. They've grown quite a bit of hair. It's almost like I dropped them on the floor or something. Much better. I mean, I've seen like these Zeners break down before, but see, that goes right to, that's the power supply pin of this chip. I would have gotten a low diode reading if that was the case. me check that little. This is a. It's actually a NPN transistor. Yeah, 0.6, which is just fine. This is the NPN transistor that is switching the voltage. It's like 16, 17 volts that comes up over here and drives this chip. And it also connects to these MOSFETs right over here. Not MOSFETs, these opto-isolators. Let me check. I don't have my notes in front of me. I'm going to go down these opto-isolators right here a second. Yeah, you really can't see what I'm doing there, though. But what if I add the microscope? Microscope. There we are. It's going to go down through here. Oh, there's worms. We were just talking about you, worms. What are you doing there, Andy? Stop retracting your messages. We're going to look at this. This is IC52. IC52 is OL on 3. And yeah, 7/10 on 4. That looks fine. About this one. Okay, this is IC53. That's ground, I believe. IC53 is ground on one side and let's say 0.687 on the other. Look at there, on the money. And this is IC51. Pin 1, nothing. Pin 2, 563. Yeah. That all looks good. All looks good. Now the thermal cam may have to come out. I mean, I'm not one to drag out the thermal cam for just anything. But it was discussed earlier. It was discussed earlier to bring it out. I think the batteries are charged. Nothing seems to be shorted. So there's no reason for it to be making my variable AC transformer hum like that. Unless this DAP053 is just bad. And it's like turning on some of these MOSFETs full time and not switching. I mean, that would give you a lot of current draw. And my meter went to sleep. Okay, it may be time. You think the, okay. You think so for the thermal cam? Well, I'd have to find my thermal cam in all this mess. Like, you know, I'd have to find it. Because odds are good, it's under a multimeter, as many meters as I have. It's probably under a multimeter somewhere. Okay. Let's see. We'll do it from this side. That's totally off. Let me get where you can see the, but there's a problem somewhere. Well, I gotta find my thermal cam. I don't have it just laying at the ready all the time. Who knows? It may not even work. Well, how about I just look at the thermal cam and I'll tell you what it said. Okay. Here we go. I gotta get ready to get some power on this thing. All right. Are you ready, Worms? Are you ready? Oh, I can see it from back here. Okay. Ooh. Ooh. Our DAP053 is what's getting hot. Looks like, oh, what's this over here? Ah, this is some kind of protection I see. Is it getting hot? I don't have those. I've never seen those go bad. The DAP053 is warming up a little, but this chip right here is warming up a lot. Yep. I think that's going to be our problem. I'm not quite sure why it went, though. It's this IC1. Let me show you. What was getting hot. Now, I don't have any of these. This IC right here, which is isolated by 150 k ohm resistors. So if you're isolated by 150 k ohm resistors, how do you cause enough current flow? Something ain't right. Something not right. It's measuring 300 k ohms across the thing. Something's not right here. You know what I mean? It's across. I can show you where this thing is. I don't think I've ever looked at one of these boards with a thermal cam to know, but it shouldn't. Let me look at that part of the, yeah. This right here. Which is isolated by 150 k ohm resistors. So, I mean, you can't really get a whole lot of current flow with that much resistance. It's some kind of protection, I say. I think it's some kind of, I don't think I've ever found a data sheet for it though. This SC1143DG. But you can see it's just, it may be a package of like TVS diodes in there. I don't know. Couldn't find any data on it. But still, I don't see how that's going to short out my damn AC input when when it's obviously isolated by 150 k ohms. For a total of 300 k across the line, which would give you a minuscule amount of current. And it measures 300 k across it. So the only other thing that was getting hot or getting warm was the DAP053. I don't understand why this is getting warm though. That little chip. I don't understand why that's getting warm. I mean, it's literally just across the AC line. And it looks like something to, to help against spikes of some kind. But again, 150 k ohms to both sides of it. Is that the same part number? Yeah, SC11430, something like that. Yeah, or 1143DG. I don't know what it is. Replace it with a wire. FET type IC from DS. What? What is it doing though? MOSFET? Let me look that up. I couldn't find anything on it. Oh, I am confused. I am very confused. But if you go 150 k ohms to each side, it can't do much. It can't limit. I don't understand what they're trying to do with it. And it measures 300 k across it. I've looked for this data sheet before. That's not it. 43. Yeah, what comes up is not. I'm looking. I did not find a data sheet for it. Yeah. So I'm not sure what it is. I mean, I don't think it can't be necessary to run. It's paralleled across the line. I'll remove the thing. Let's just remove it. And we'll just keep going. Can't get hot if it's not installed, can it? It doesn't look like a FET though, you think about it though, because there's no gate. There's no gate whatsoever. So my guess would have been some diodes, some type of protection diodes. Probably should put some flux on this. We're going to come off of there. There we go. All right, we're removed. Well, it can't get warm now, can it? I just don't think that's our problem. Go back to the overhead. I see something with that. I see a PWM coming up or something, but that's not a PWM of any kind. All right. It's out. Thermal cam is still running. It's a little warm where I took that chip off. See if I can give it some power now. Hang on, I need to be able to watch this voltage. I do like to watch that PFC voltage just to make sure it doesn't do anything stupid. I don't like capacitors blowing up in my face. Okay. My desk is cluttered right now. Let me get these leads out of the way so they're not blocking something. Still pretty warm right there. All right, I'm going to apply power to it now. Now, look at that current. Now, we're drawing an amp at 40-something volts AC. We're drawing an amp. Where is that going? Aha, 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 ha, 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 ha. Right there. Maybe that's what it was there. Maybe I was looking at the wrong object. I don't know. It was, we'll see. Diode. Big fat diode. Big fat diode right there. Didn't I check that diode? Pretty sure I did. It kind of stands out there. It's large. So it may not have been shorted, but maybe it's breaking down. Man, I'm getting cluttered here, fellas. The clutter is taking over. It's messing with me. Naughty diode. It is a naughty diode. I have a feeling it's. That kind of makes sense. That diode is on like the front AC input. It's very close to the front end, so that could definitely give you a lot of current flow. Did I not check this diode? Make sure I did turn this thing off. All right, what do we have? 0.3877. 1.7. That diode may be good. That is D1. I may have to open up another supply and compare, but that doesn't look like a bad diode. I mean, there's some capacitance involved. I might have to just lift one end of it. 0.388 looks fine there. So let's lift one end of this diode. We'll just lift one end of it and check it that way. As soon as I find my solder wick. I gotta turn off this thermal camera. What I'm saying is diode may or may not be bad. It could be there's a short just beyond it and we're forcing a lot of current through it, you know. So it's getting hot because we're forcing a whole lot of current through it that it doesn't like. Just a second. Got to get where I can see. They glued all these things down. So I'm just going to lift it. Lifting the cathode of it. Let go. There we go. All right, I got it lifted. Got it lifted. What does it measure now? It's out of circuit. 0.4 and in the reverse direction. Perfect. So I think our diode is fine. I think it's got a short somewhere beyond it. D1. 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 A lot of current. Oh, let me show you. There's D1. Connects from the basically from the bridge rectifier to the other side of the where the PFC boost is. We had a. Let me look at something. Shoot. That's what I was afraid of. That's what I was afraid of. I know what happened. I know what happened. Y'all made me nervous. Do y'all know what happened? Anyone want to guess what the problem is right now? Anyone care to guess what the problem is? Some idiot installed a capacitor backwards. And you guys let him do it. You sit there and watch me and let me do it. Yep. Yep. So, now that kind of makes sense. Kind of makes sense now, doesn't it? Yeah, kind of makes sense. Can you see? I don't know if you can tell. This should be the negative terminal right here. Yeah, that capacitor's hot. Yep. I'm not going to reuse that capacitor. I will replace it with another one because I have stressed it. Oh well. Well, the thermal camera didn't see it because I had the board flipped the other way. We were looking at the bottom because I was expecting a problem on this side of the board. So it was, anyway, it lit that diode up, didn't it? Because all that current was going through that diode. Which, don't let me forget, I got to put that diode back down. That capacitor is toasty. We'll even look at it with the thermal cam. Wake up. Wake up, thermal cam. As soon as it calibrates itself. Look at that thing. And there's my finger. What is it showing? 50, 52 Celsius? Yeah, it's cooled off a little. So yeah. Don't reverse polarized capacitors. All right, now maybe we can make some progress with this thing. I do hate it so much though when I get in my own way on a repair. It happens though. It happens, whatever. It will happen. But I swear I looked really hard at how that thing was supposed to orient it. Right, like that's wrong. Negative terminal, negative, negative. All right. What could go wrong? At least I didn't just throw a full voltage to it and, you know, let it blow up in my face, because that's what it would have done. It would have exploded. Or it would have vented, you know, the vent would have popped out the end of it. Or actually, probably what would have happened is my, either the line fuse would have blown or the fuse in my Variac would have blown. If it would have, because it was drawing over an amp at 40 volts AC. If I'd gone to 120, they'd been allowed, and then boom. But that's why we bring it up slowly. That's why we bring it up slowly. All right, that capacitor is definitely turned the correct way, the same way as the other one right beside it. Hot glue. So, put it out of the way. The capacitor is garbage. I need to put that diode back down that I lifted. I'll leave that little IC off for now. Don't think it's necessary to just test. All right, that diode is back down. What else did I do? Okay, are we ready to test again? Are we ready to test again? Alrighty. It just hit me when I was, right before I figured out, you know, I was like, where would all this current be going? What would be shorted? Oh, wait. Oh, wait. Alrighty, wake up meter. Let's switch so we can see. All this kind of stuff. We are metering across our PFC voltage again, trying to minimize the glare. Oh, this is getting to be a mess. Alrighty, this is on. This is set for 5 amps. What's it going to do this time? Well, it's not going to do what it did last time, I'm pretty sure. Oh, the load. Need to connect the load. You don't have to. These will run without any kind of load on them. These supplies don't care. But for testing purposes, I do like to see some current draw. All right. All right, we're going to do the same thing. Can you see everything? I'm going to turn on. I'm going to start easing up the AC voltage. All right, there's 50 volts. I'm going to check the current. And next to nothing. There's nothing there. I'm going to bring it on up. And she's starting, and she is running. Hallelujah. 395 for our boost voltage. Love it. Love it. I turn my little fan on. So yeah, this repair would have been done a long time ago if I had not put that capacitor in backwards. Oh, I do need to put that IC back on. I do. Yeah, let's do that. I do have it. I do need to put that back on. Still don't know what it is. Did y'all figure out what it was? Because I've never been able to find a data sheet or confirm, you know, what that was. It's across the AC line, so I'm assuming it's some kind of spike suppression or something. All right, we're running. I will put this chip back on, though. Turn that off a moment. Let me get my discharge tool. And these capacitors are in parallel, so you can put the discharge across either one. So our DAP 053 was good. No problem. All right, I discharged it. I'm going to have to take these leads loose to be able to get it flipped over here. There's where that thing went. I'll switch back to the microscope. And there it is. I think what I'm going to do is just clear this off. We'll just solder it back down by hand. Like so. Yep, there's pin 1. Now where is my solder? Somewhere hard to reach. I got it. All right, we are reinstalled. I should have checked that thing while I was out of circuit, though. I think it's all right. We might take a look at it again with the old thermal cam. I really don't want it getting hot. So it's for discharging? I could see that, maybe. Be a slow discharge though with 150K. You know, that's what it's hard for me to, it's 150K to either side of it, to each line. It doesn't sound like they want it to do very much if you're going to put that much resistance in series with it. All right. Let me get my load hooked back up. Maybe I can hook my PFC meter. We'll keep it flipped this way this time, so maybe we can see what we need to see. Okay, I'm gonna cross it there. Positive, negative. Thermal cam at the ready. Okay, are we ready? Go ahead and dial it back down. Let me set this at about 50 volts AC. And that chip is just as cold as it can be. I'm not sticking my finger too close there. Where is it? It's that black blob right in there, that dark area. That's where it is. You probably can't. Let me switch to the other. Let's switch to the other view. Maybe you can see the thermal cam a little bit better. It's cold though. That chip is cold. Bring it on up. And we're running. We're drawing 5 amps. There's our DAP 053, getting a little bit warm. 40, 43. A diode right there gets a little bit warm. Oh, that chip is starting to warm up a little, isn't it? Well, no, that's the diode. That's that diode that was getting hot earlier. Slightly warm, but that maybe I just looked at the wrong thing. Maybe it was that diode getting warm the whole time, and I thought it was this chip. They're close. Maybe that's the issue. And they're similar size. Well, it's back reinstalled. And everybody is happy. All right. Yep, large capacitor was backwards. We're not sure who did it yet. We're looking for the guy now, though. We'll find him. He won't escape justice. Yeah, it's looking good now. It's working. I do need to do the full load test on it though. Run it up to like 30 amps. I mean, I can run it up to 10 amps now. And you can see we'll be drawing 1.4 amps off the AC line. The voltage actually starts to dip a little. The AC does. That looks healthy though. The PFC voltage holding at 395 is what you want to see. So let's just I'll turn that off. Turn off the load. Let's move this back to the AC outlet back here. And we are running. Turn the load on. There's 10 amps. Let's crank it on up. See what happens. 20 amps. Let me get where I can measure this DC voltage. Right across these terminals. 11,965. 64, whatever. Okay. She's still holding. We're going to crank it on up though. PFC voltage holding steady. 30 amps. 30 amps. 347 watts. The voltage is a little bit low. These leads aren't meant for 30 amps of current. But if she'll do that, she'll run a PS5 all day long, forever. Put it back to 5 amps. That's fixed. That is fixed. Took longer than it should have, but sometimes it does. Yeah, these are rated at 31 amps at 12 volts. Now, if you look at the, I think I showed y'all before, where is this one? This monster for the PS5 Pro is rated at 12 volts, 35 amps. That really shows up too well. It's a beast. It is a beast. They use 2 transistors for the power factor correction, and they'll use I think they're still using 2 for the DC-DC converter part, but the rectifiers on this side, instead of 2 MOSFETs for the rectification, there's 4. 2 sets of 2 in parallel, I guess, to increase their current capacity. And the Pro supply seems to run at 410 volts DC. Instead of the 395 or so, it runs at 410. My testing. I don't know why I mean, they want some overhead, I'm sure. I mean, the PS5 probably draws like 10 amps or something. I'm sure it varies according to what you're doing. But they did seem to build in a lot of overhead. Okay. That's 2 supplies. Throw all that away. Turn this off. Discharge this. There we go. Another spare supply. Sit in there. All right, where's my lid? There's the lid. So that one we had to replace capacitor, the 2 MOSFETs, the fusible resistor. Not too bad. Where? Oh, there. Okay. Okay. This is a ADP 400 FR repaired. See if I can stick that right about there. Where's my tape? Here's my tape. All right, that will join the other two from earlier. Oops. Now what do we want to do? Do we want to do another supply, or do you want to just let it go? I think a roach may have got this one. Yeah, I think I did. Roach did damage this one. Fix something else? Like what? I mean, I have a PS5 here. I'm looking at what time it is. On to the next one. I have supplies. I have a dead PS5 also here. Oh, JFix going live in 30 minutes? Is that true? Is he going at, well, I guess it's 1 my time? Yep. Okay. Well, I don't want to step on JFix. Let's see. Let's try to grab another supply, because the PS5 could take a while. I think I have another, yeah, another FR here. Let's do this in quick. How quick can we do it? How quick indeed. This supply seems a bit dirty. Don't know if it's dirty on the inside or just on the outside. Oh, come on. This is another, yeah, FR. And I have not tried to plug it in because I like to, I mean, I'm assuming they're not working. That's why I have them. Oh, come on. There we go. And a roach fell out. Two dead roaches fell out. And I have burn marks. I see scorch marks in here. Let me get rid of our guests. Yeah, we have guests. I know I saw a scorch mark somewhere, and now I don't see it again. Oh, just right here. We'll look under the microscope. Right in there. Yep, somebody took a step there. They probably shouldn't have. So, and that is right on the 400 volts. There's the filter cap. So, did this maybe just blow the fuse or something? Or could we be that lucky? It just blew the fuse? Because I mean, if it gets across it back here in the AC circuitry part of it, it shouldn't damage any of the, DC-DC conversion stuff. Shouldn't. And there is an ant and some kind of nasty corrosion there. Yep, gonna have to clean my workbench again. Not sure what's going on there across that capacitor. Anyway, we're trying to do this quickly. No dilly or dallying. I was just getting what I could obviously see there. No components with their tops blowed off in this one. There's another leg. Okay. What do we have? What do we have? Did our gross. It's nasty. Yeah. Nasty. Nasty. All right. What was I saying? Our fuse. Fuse is good. Okay. Fusible resistor is open. MOSFET shorted. Okay. MOSFET shorted. So, is that all it got? It's very common that's all it gets is those, you know, these MOSFETs, pops a fusible resistor. But every now and then, you know, they short to the gate and you end up with 400 volts or whatever going back into your DAP053, which is not on the approved list of voltages. We'll check it though. We'll check it. Try to do this one quick. Oh, my stomach is growling. It's lunchtime. I have missed lunch. Out. Oh, come on. Oh. That's still attached. Out. Oh, come on, just come out, resistor. Just make it easy on yourself and me. They bend these legs over. All right, now with those out, what do we get on our DAP053? What do we get? Find the negative end of that capacitor. Let me turn it this way. Pin 1 looks good. 2 is good. 3 is good. 4 is ground. 5, good. 6, good. 7's no connection. 8, 1.47. That's high because the MOSFETs are out. That looks good. That's no connection. Good. 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 All right, it looks good. DAP053 looks just fine. Could still be bad. Let's pop some MOSFETs in here. A fusible resistor. What is that? Let me clean that a little bit on this side of the board. Looks like where a roach has been walking. Just cleaning it up a little as I go. All right. MOSFETs in. MOSFETs in. Oh, come on. Fusible resistor, 0.1 ohm. All right, how much time I got left? Oh, like 10 minutes or so. No problem, as long as I don't install something backwards. Where did that go? Toothbrush. Trying to make sure I didn't drop one of the leads I cut on the board. So if it's laying there, I want to knock it loose. Okay. All right. We're nearing showtime. Watch our PFC boost voltage there. Negative, positive on the load. Try to get where you can see it. Dial that down. Yeah, That's a little bit better. Okay. These capacitors. Oh, one of these is a little bit swollen. This one here has just got a slight bulge to it. Probably have to replace it too. I don't think it's failed, but it's been warm. All right. Turn on the load. We're set for 5 amps. And this is turned all the way down. We're going to bring it up slowly. I'm going to get my arm out of the way so that you can see the DC load if it were to decide to start. And it does start. Although, let me check this voltage. Yeah, 11.975. Seems a little bit lower than usual. $11.97 right across the terminals with a 5 amp load. Boost voltage running at 394. So yeah, again, roaches win. That's very typical for a roach-damaged power supply. They get those 2 MOSFETs, and when they short, the fusible resistor burns open. Well, there you have it. There you have it. Well, thank you. Fixed. I think it's fixed. Thank you, thank you. Thank you all for coming. Oh, well, you've got to be really careful. Is it I'm not sure, illidope? You just have to be very careful. I mean, I always say, you don't want to be afraid of them. You know, it's hard to work on something you're afraid of, but you need to respect them. You definitely need to respect the power supplies. But yeah, having an isolated, that Variac I've got is isolated. That's handy. So that's something good to start with. And the video I'm getting back is really delayed, so I'm not really sure how far the chat is and all that. Well, hope y'all enjoyed that. I'll get out of the way so JFix can roll on in here and entertain you. But maybe we'll do it again soon. I've got many more supplies. I've got about, by the end of the day, I'll probably have 4 PS5s to fix. So yeah, there's plenty of stuff coming. So anyway, thank you for coming. Thank you for joining me. I had fun. Hope you did. We'll do it again soon. See ya. 3, 2, 1. Bye.